In this video, we're going to look at integrals of products of sine and cosine functions, as well as products of two sine functions and also products of two cosine functions. The basic strategy is to apply a trigonometric identity and then do a U substitution. So this is actually going to be fairly easy. Once you apply the trig identity, the resulting integral will be very easy to solve by doing a U substitution. So looking at the first integral, we have sine of mx times cos of nx dx. So we're going to call this part a, that's a is mx, and b is nx. And now apply the trig identity, so we have mx, that's a, and b is nx. And that's equal to 1/2 sine of a minus b, so we're going to have mx minus nx. And plus sine of a plus b, we're going to have mx plus nx. Second integral is a product of two sine functions. We have sine of mx times sine of nx dx. So that mx, this part is a like before, this part is b. And we have mx here, sine a, sine b, that will be sine mx, sine nx. That's 1/2 cosine of a minus b, that's mx minus nx, and mx plus nx. The third integral is a product of two cosine functions. So we have a here and b here, and similarly, we're going to have mx here, nx, and just like before, a minus b would be mx minus nx, a plus b would be mx plus nx. Let's look at some examples. All right, so what we have here is integral sine of 3x times cos of 5x dx. So we have a product of a sine times a cosine function. We're going to use this trig identity, sine a cosine b is 1/2 sine of a minus b plus sine of a plus b. So what we have is integral sine of 3x cosine of 5x dx. That's going to be equal to integral 1/2 times sine of a minus b. Well, a is 3x, this part is a, and 5x, this part is b. So sine of a minus b will be 3x minus 5x, that's negative 2x, plus sine of a plus b, that's 3x plus 5x, that makes 8x, all integrated with respect to x. So we have integral 1/2 sine of a minus b, that is minus 2x, plus sine of a plus b, and that's going to be 3x plus 5x, that makes 8x, and all integrated with respect to x. Let's now split up the integrals and solve. So we have 1/2 integral sine of minus 2x dx plus 1/2 integral sine of 8x dx. Now reversing the chain rule, integral of sine of minus 2x is going to be, integral sine is negative cos, keep the inside intact, and divide by the derivative. We're just applying U substitution with U is equal to minus 2x. So divide by minus 2. Plus 1/2 integral of sine of 8x, that's going to be minus cos of 8x, and divide by the derivative, divide by 8. So in the second integral, we're doing another U substitution. We're letting U be equal to 8x, and du is 8 dx. But because this is very easy to do, we're just doing that mentally. So now let's simplify this. Double negative is a positive. 1/2 times 1/2 is 1/4. So we get 1/4 cosine of minus 2x minus 1/16 cosine of 8x plus constant of integration plus c. All right, let's look at another example. Here we have a product of two sine functions. So we're going to apply sine a sine b is equal to 1/2 times cos of a minus b minus cos of a plus b. So like before, this part is going to be a is 2x, and b is equal to 4x. And what we get is integral sine of 2x times sine of 4x dx. That's going to be integral, that's 1/2 times cosine of the difference of a and b. So that's a minus b, that's going to be 2x minus 4x. That gives us minus 2x. Minus cos of a plus b will be 2x plus 4x. That's going to give us cosine of 6x. Let's close the bracket and integrate it with respect to x. So now let's split up the integrals, and we get 1/2 integral cos of minus 2x dx minus 1/2 integral cos of 6x dx. The first integral is basically we're just applying U substitution. Let U be equal to minus 2x du is minus 2 dx, and say w equals 6x for the second integral, and dw will be 6 dx. Alright, so the first integral, we're going to get 1/2 integral of cos is going to give us sine of minus 2x, and divide by negative 2, reversing the chain rule or applying the U substitution, minus 1/2. Antiderivative of cosine of 6x is going to give us sine of 6x, divide by 6. Again, we're doing U substitution where u is equal to 6x, du is 6 dx. I just use a different letter w just so that we're different than the first letter u. So w is equal to 6x, dw is equal to 6 dx. All right, let's simplify this, and we get negative 1/4 sine of minus 2x minus 1/12 sine of 6x plus c. Now in both questions we did a lot of U substitution, and sometimes we did that mentally, and so I want to expand on that and do that more formally. So if you have an integral of the form sine of kx dx, how do we go about solving that? Well, we're going to apply U substitution. We let u be equal to kx. Its derivative du will be k dx. Divide both sides by k, and we get 1/k du is equal to dx. So let's now transform the integral in terms of u. So we have integral sine of kx, that's u, times dx is going to be 1/k du. 1/k is a constant, passes through the integral. We get 1/k integral sine u du. Now antiderivative of sine u is just going to be minus cosine of u. That's going to give us minus 1/k cosine of u plus c. And I should also put a plus c here as well. Now put u back in. U is equal to kx, and we'll have the answer. Negative 1/k cosine of kx plus c. So when we did integrals of the type like integral of sine of 2x dx, we simply said, oh, that's going to be minus cosine of 2x divided by 2 plus c. But we were really applying the substitution technique, but because it was easy, we just did that mentally. All right, thank you.